All right, welcome to day 84. Today, we're diving into a technology that's quietly changing how we find things. It's all about moving past simple keywords and starting to understand meaning itself.
So, how does a music app know exactly what you mean when you ask for a song with a certain vibe? I mean, you're not searching for an artist you already know. The app is somehow matching of feeling. And that's the key, right? This isn't about matching text, it's about matching meaning. And that's a huge shift in how we think about data.
Think about how rigid old school search is. If you search for smartphone, you get smartphone. That's it. It's built for exact matches. But what we really want is a system that gets the context, one that understands cell phone and mobile device are basically the same idea. To do that, you need a totally different way of retrieving information.
And that's exactly what we're going to cover. By the end of this, you'll get the core intuition behind vector databases. This is the tech that's making all of this contextual AI possible.
Okay, so let's get into the core idea. To really understand how vector databases work, we first have to ask, why do they even exist? What problem are they solving? Imagine a traditional database as a library, a really well-organized one. Every book is sorted alphabetically by the author's last name. Super efficient, right? But only if you know exactly what you're looking for. The author's name, the book's title. It's a system built for data that's neat and tidy.
But what if you don't know the author? What if you just want to find a book with a similar idea? Well, that alphabetical system, it completely falls apart. And that's the exact challenge we have today, because our data isn't so neat and tidy anymore.
Yeah, we're not just dealing with simple rows and columns these days, we're dealing with a massive amount of unstructured data. Things like text, images, and audio. And it's growing like crazy, somewhere between 30 to 60% every single year. All this complex, kind of messy data, it just doesn't fit into that old, rigid library model.
So, a vector database basically rethinks the whole library. Instead of sorting by author, it sorts by meaning. Books with similar themes or styles get put on the shelf right next to each other. So now, if you find a book you love, you can just look at its neighbors to find others with a similar vibe. That's the core concept right there, organizing by similarity.
Okay, so that's the why. Now for the how. How does this, magic library actually work? Well, the trick is to turn all that complex data into simple coordinates on a map. The key piece of tech here is something called a vector embedding. So what is it? It's basically a process where an AI model takes something complex, a word, an image, even a sound, and translates it into a list of numbers. And this list of numbers, this vector, isn't just random. It's a numerical fingerprint that captures the actual meaning of the original data. The process itself is pretty straightforward. You start with your unstructured data, let's say a document. You feed it to a special AI model called an embedding model. Its only job is to spit out a vector. And then that vector gets stored and indexed in the database so it can be searched. And here's the cool part. Look at how these numbers behave. The vectors for car and vehicle are really similar numerically, which makes sense, right? They mean similar things. Same for cat and dog. But the vectors for cats and dogs are worlds apart from the vectors for cars and vehicles. So the distance between these numbers actually represents the difference in their meaning. So when you search for something, your search query also gets turned into a vector. The database then uses some really clever algorithms like approximate nearest neighbor to find the vectors in its collection that are closest to your query's vector. And this whole thing is blazingly fast. We're talking about finding the closest concepts out of billions of items in just milliseconds. This ability to find similar concepts at incredible speed is exactly why vector databases have become a fundamental building block for modern AI. And you see this technology everywhere now. It's what's behind those recommendation engines we talked about. It's the engine for semantic search. And, really importantly, it acts as a kind of long-term memory for chatbots and other conversational AI. Probably one of the biggest use cases right now is something called retrieval augmented generation, or RAG. The idea is simple. Before a large language model answers your question, it first goes and searches a vector database for relevant facts. It then uses that context to build its answer. This helps ground the model in reality and, well, it helps stop it from just making things up.
And this isn't some niche thing either. The industry is adopting this stuff fast. Gartner actually predicts that by 2026, more than 30% of all large companies will be using vector databases to build smarter, more context-aware AI.
All right, let's wrap this up with the key takeaway. So if you remember just one thing, make it this. Vector databases work by storing numerical representations of meaning, and this lets us search for similar concepts, not just keywords, at a massive scale and with incredible speed.
And that leaves us with a really interesting thought. Now that we can turn these complex, abstract ideas into searchable coordinates on a map, what other hidden relationships are out there, just waiting for us to explore?